Thanks for tuning in to another Taproot Root Cause Analysis webinar. I'm here with Ken Reed, and he's going to talk about some stuff that I don't know a lot about.
A lot of people don't know a lot about these kinds of things. So we're going to talk a little bit about one category on the root cause tree that comes up fairly frequently during investigations on kind of how the humans interact with the equipment.
Okay.
And not just the equipment necessarily, but their entire environment, how the environment and the people interact with each other.
What's that category called?
It's called, in our system, it's called human engineering.
Mm-hmm.
Some companies and different experts call them different things, human engineering, human performance, and things like that. But we specifically call it human engineering in our system.
And you've got some pictures for us to look at.
I do. So this is one of the areas on the root cause tree that I think a lot of people miss. This isn't something that most people are trained on. A lot of people inherently know about procedures and they know about training. And they know about supervisors and things like that.
Right.
But they're not necessarily trained on what color a light should be and what shape a knob should be. It's not something we're normally trained on.
Or why that's important.
Or why we care about that.
We're going to talk about.
Exactly. So this part of the root cause tree is one of those areas that for me is a lot of fun because when I first started working here at System Improvements, I wasn't very familiar with this stuff. Although after you see it, you kind of recognize it's a problem, but you don't realize it until you know a little bit about it, why it's so important. So I find this to be a really cool area. The other piece of this section of the root cause tree is it's really easy to just blame the employee when something goes wrong without understanding why that employee made that mistake. And it could very well be because of the shape of the knob or the color of the alarm light or the tone that the alarm was going.
Right.
And it's so easy to say, I can't believe the guy turned the valve in the wrong direction. Well, when you go down and you look at that valve and see how the hand wheel's set up and how everything's arranged, well, now it makes sense why the guy made a mistake. So this is one of those cool areas that it's very easy to just point your finger at the employee and say, I can't believe the guy made that error. But when you start really looking at how the stuff is designed around how humans work, it makes much more sense that way. And we've all experienced a lot of these problems that we're going to take a look at here. And whether you realize it or not, you've probably seen these problems and it's like, oh yeah, I've seen that before.
All right. So we'll have to take a moment to look at the picture, give time for people to digest what they're seeing, and then we'll,
Sounds good.
Pick it apart.
Sounds good.
All right.
So the first one that we've got up on our screen is just a very simple control panel picture.
Simple. Okay.
Simple. Really, these are just on-off switches. You just push a button for what you need to happen.
I see some labels on there.
Kinda.
Labels on top of labels.
If you look really close, you may see those labels. If you look really close, you'll see they're not in English. So that could be a problem right there, depending on the operator, right?
Some of these round buttons, I see 3 at the top, 2 at the bottom, but then sometimes the one on the right-hand side bottom is red, but not on others.
So what does that mean? Does that mean something, or is that just the color of button they happen to have when they put this control panel together? Is that an emergency stop button that's in red? Is that my start button? Is that the one I should never push? What is that button?
There's a little toggle lever thing up here on the other one.
That's right. There's a lever up there on that one, and maybe some indicator lights at the top that are not all labeled, so you don't even know what those lights mean. So you can imagine if somebody had been operating this panel and we made some kind of an error. We overpressurized a tank. And then it's very easy just to say, bad employee overpressurized the tank.
Yeah.
And then you go down and you look at the control panel and you say, well, how did this guy overpressurize the tank? And whenever you have a human engineering issue, it's very, very important for the investigator to actually go down and look at what the operator is physically doing. This isn't one you can just say, interview the guy and say, tell me what you did.
Right.
Because he's going to tell you why I was pushing buttons.
You want to physically see what he saw.
You've got to see what he saw. And if
or
you
she.
can, or she, what they saw. And put yourself in their position. What were they physically doing? And body position is important sometimes, and vision, where were my eyes pointing when I was supposed to be pushing these buttons? That all goes into the human-machine interface piece of this. And is oftentimes very poorly designed. So this is a great example of it's probably a simple control panel to operate. You're just I'm going to say, I don't know if this is true, but you're probably just starting and stopping some pumps, maybe opening and shutting some valves or actuators. But you can easily see where either the color of the button makes you make an error, or the poor labeling makes you make an error. The position of where the button is located can have you make an error. So these are all the kinds of things that you should be thinking about when you're thinking human-machine interface and how could the human have made this error. Okay. This is another problem. This is actually an old-fashioned hot plate is what this was, control. And it's got a couple of controls on it. And as you look at it, it's even hard to figure out what it's trying to tell you. So the top one goes from left, and as you turn it counterclockwise to the left, it goes from minimum to maximum temperature. And then the one below it has a minimum and maximum dual control. And I believe what this is for is an inner and an outer heating element on this. So you can heat up the inner and the outer one depending on the size of the element that you want to use. And you can just imagine trying to figure this out as you're looking at it. What is this switch trying to tell me? What's this control trying to do? And if you just reach up there and quickly grab the wrong control and turn it the wrong way, you've either turned the wrong heater on, you've turned it hot when you wanted to turn it down, you've just made some very easy to make an error with something like this. Stove controls are always an issue and can cause problems. So I think most of us have probably experienced stove control problems, right? Where you've turned the wrong burner on, or you thought you turned this left-hand burner on and that one's on, you burn up an empty pan, those kinds of things.
Guilty.
I've done it too. It's amazing how easy it is. And they're not standard, so everybody's stove controls are different. And you just got to read the label and hope you're pushing the right one, right?
Every time.
I still do it. I've had this stove for 15 years, and I still have to, which burner is this one? I got to look on the back panel and see what the little white dot is. So yeah, it's easy to make those kind of errors. So that's another example of a control that can cause errors and cause people to make mistakes. So the next one we're going to look at, this is an elevator control. And it's not obvious on this what the problem would be, but when you step back for a second and look at it, why is there 2 up arrows and 2 down arrows?
Are they on like the doors on either side?
That's what the initial thought was, but what it actually ends up being is the right-hand one is just the indicator.
Oh my goodness. So the other one's like a dead button. It doesn't do anything.
Well, the left one, you actually push it and it moves, but the right one is where it's going.
Wow.
So you can't push the red one there.
Yeah.
You have to push the one next to the red one.
And they look identical. Somebody's going to think the elevator doesn't work.
That's right.
That's me. I'm walking, stomping off to go take the stairs or another elevator.
That's exactly it. I'm the same way. And it's elevators to me, since I travel a lot, elevators, most of them you can figure them out pretty quickly, but they're not always obvious. And they all try to use the same, at least within like the US or Europe, they have the same letter designations and number designations. But if you get outside of that, when I go to Europe, the ground floor is not floor number 1, it's floor 0.
Okay.
So floor 0 is the ground floor. In the US, it'll have either a 1 or a G sometimes. And then they have a garage. So is the G going to the garage or is that going to the ground floor, right? So again, elevators should be obvious where you're headed. Even sometimes the audible indicator of where it's going, what it's doing, is it when it arrives at the floor? Do you get an audible alarm? You know, do you hear the ding when it shows up?
That's nice when it does.
It is.
There's times where there's multiple elevators, you push the button, and then you're doing this dance of where's and then there's like some tiny little, like almost stall elevator way down there, and you miss it, and you're like, okay, now I got to start over.
I just start over. Yep.
How was I supposed to know? It's way down there.
Or they've got the alarm. The ding is over here, but it's the elevator over here. So and you're looking for the right elevator. And these are all human factors things. And the elevator is kind of an easy example of that. But you can imagine if you were operating in a control room somewhere and an alarm goes off over here, where it makes you look over here, but you need to do something over here. So those kind of human factors things, unless you've thought about them ahead of time, can cause errors.
That's a good point.
To make mistakes.
Like that.
Elevator is very simple. Obviously, if I miss it, well, I got to push the stupid button again and do it again.
Okay.
But in a more dangerous situation, it can be an issue if things don't line up like you expect. We've all had problems in our cars.
Yes.
Right?
Okay.
Trying to figure out which lever does what. And as these vehicles get more complex, have more functions built into them, they've put more and more of these stalks on. And it's very simple to try to figure out, all right, I want to turn the cruise control on here. Which one of these is cruise control?
I'm still trying to figure that out on my car.
And yeah, exactly. And now, for example, Tesla has decided they're getting rid of all the stalks. There's no stalk anywhere on the newer Teslas. They're going to go straight to, even the turn signal is no longer on the stalk. They've gotten rid of that. Is that good or bad? Well, it depends, I guess, what you're used to. I'm not going to say whether that is good or bad.
I'm conditioned to have certain things in certain places in different cars. It's like, this was always where the windshield wiper part was. You know,
Exactly.
I've got a front and a rear. I know how to do that. But then everything starts moving around.
Yep. You go to a new vehicle.
That's easy to make a mistake.
And I travel a lot again, so I get into a
rental car. Yeah.
I've got to figure out how to turn the mirrors, how all this stuff works.
Yeah.
Funny story, I was in Australia for the first time driving, and I'm driving down the road, and I swear every time I wanted to turn right, the windshield wipers came on because they swapped the stalks.
Yeah.
So you click over here where we call proprioception, where you expect that thing to be, and you click it up. That's the windshield wiper. This is a control. The turn signal's on the other side.
You're like,
of the
this
column.
guy's clearly visiting. Yeah.
Yeah, exactly. It's funny. I actually got pulled over by law enforcement one time because what did I do wrong? I didn't have my lights on or something, or did I flash? I don't remember what I did. It had to do with the lights though, and she was funny. She was hilarious, but she was also in Australia, and she was laughing at me because I couldn't figure out which stalk I was doing. But yeah, so car controls. That is a life and death thing. You've got to be able to operate your vehicle properly. And when you make a mistake on, hitting the brake or whatever, and you see people making these kind of errors, oftentimes it's because they're not familiar with that particular vehicle, and it's a little bit different.
And then add in the distractions, somebody, hopefully they're not texting and driving, but I'm sure they're doing things, and then everything's so different. And when you need to react, when you need to do those things, then you're,
that's exactly
way out of your element.
Yeah. And you only have a split second to make that error, right? And then before something bad happens. So vehicle controls. We had bought a new Ford Edge one time when they first came out years and years ago, and my wife called me one time while I was at a conference. She called me, and we only had the vehicle for like a week, and she said, "Can you tell me how to turn off these emergency flashers? I don't know why they're on. I'm on the side of the road and the stupid flashers are on." And I'm like, I don't remember. We've only had the car for a week. So she's looking around. She finally found it. It's right in the front of the dashboard. There's a button right there in the middle of the column. Well, this stupid thing has a little display there. And as you're driving, when you push buttons, you push the touch screen. Well, the emergency flasher, it's got a little shelf to put your hand on to steady your hand. The emergency flasher is right below that shelf, and it was a touch button. It wasn't a click button.
Okay.
So all you had to do was brush your finger across it, and it turned the flashers on. So I went to a human factors course up at the University of Michigan, and they have all the car manufacturers are there. And there was a Ford guy there. And this was like 2 months after this. And I walked up to him and I said, "Hey, I got a question about one of your cars." He said, "Yeah." I said, "The Ford Edge." He said, "Oh, the emergency flashers." I said, "Yes." He said, "Yeah, we recognize we screwed that up pretty early on. It's like the number one thing on our list to change on the next model year." So they knew about this human factors problem that they put in place. So it was pretty funny. he was hilarious. So anyway, vehicle things and distractions that you had mentioned. We got these big panel displays now sitting there next to our right in our field of vision right there.
Yeah.
So there's a lot of stuff to think about with these new vehicles. And I haven't decided yet whether I'm thinking we're going in the right direction or the wrong direction, but things to think about on vehicles.
Oh, yeah.
So anyway,
what
some
else
good stuff on human factors. That's just kind of a funny joke here. A lot of times, what we're trying to show here is a lot of times we just try to train our people to be careful. Don't turn the wrong switch. Don't push the wrong button. Well, if you've got to train your people not to push the wrong button, that's probably telling me there's a human factors problem. You shouldn't have to train people not to push the wrong button. It should be very hard to push the wrong button.
Yeah.
So that's a human factors problem. It's a human-machine interface issue. It is not a training problem. If you ever have a training root cause or a corrective action pop up because somebody turned the wrong switch or operated the wrong valve, or it's probably not a training problem. It should be designed so that the operator doesn't operate the wrong thing.
So there was like a key thing you said there about it's hard to do wrong?
It's hard to do wrong, yeah.
All
You
right.
want to make it hard to do incorrectly. You want to make it easy to do it the right way and hard to screw up. That's what you want. And if you're going through and training your people to be more careful, it's probably not the right corrective action.
Yeah.
So just something to think about with those kind of human-machine interface problems.
Is that a fork?
It is.
And a rubber band. Okay, so we're having our own little contraption to be able to open the door handle.
That's right. So now this is because I'm sure he broke the door handle, but what I'm trying to kind of get across here is that when we have a bad human-machine interface issue, humans will find a way around it. They will figure it out. Whether it's the right answer or the wrong answer, they're going to have some kind of a workaround to do it the way they want to do it. So when things are designed poorly, or in this case broke and not fixed, the human is just going to say, well, I'll figure this out on my own. And they'll do something they're not supposed to do because the way the machine is set up doesn't help them operate the machine.
I see.
So this is a great example of putting a rubber band and a fork in there to make sure that they can operate the piece of equipment the right way.
But in the older vehicles, I think this is a common thing where that is one of the components that breaks often.
It is
that. The material, the plastic, is it in the hinge? I mean, there's a lot of different things to think about.
Right.
So in place of business, if you have something that continually is breaking, why do my people keep breaking my stuff?
Yeah.
Well, maybe it's not them breaking it.
So instead of just yelling at the guy and say, hey, don't break that again. I'm tired of you guys breaking this piece of equipment. It's probably poorly designed. Is probably what the problem is. So that's a great example. And instead of just focusing on the person, we should be focusing on how to make it so the human doesn't make the error.
But what we do instead, the norm out there is to go more training or discipline. Don't break this. Make sure you do it the right way. Exactly. Oh, we're going to put you in training again on how to operate this.
Yep. So anytime I see somebody that, again, kind of what we had mentioned earlier, when you see somebody's corrective action that has trained them not to make that error or break something or push the wrong button, it's probably not a training problem. You're not going to be able, and the reason I say that is because you will not be able to train people to do this. It will make sense for them for the first week. They'll remember it, and then they forget about it.
Now, I'm going to go a little left field for a second. If they're following directions, if they're using a procedure and you can verify that, then we look at some other stuff too. We've got to we can't just go, oh, you know what, this is a problem with human factors or engineering or whatever. You've got to also look at all the other things.
So that's a great point. So it is rare that there's a single root cause to a problem. Yeah. So if something's poorly designed, that's one problem, the design of it. If we are allowing our operators to do workarounds like this, well, that's another problem. If our procedure doesn't cover what they're supposed to do, that's another problem. And usually you'll find that these all line up. These different problems all get together at the same time in order to cause an incident.
And then people have the workarounds because there's pressure for production, things like that. And it's like, hey, you wanted it. Here's your parts.
There you are. You said it had to be done.
At the sake of the machine, now that we've destroyed something, I get you.
So that all fits together in there. And it's rare that there's a single problem. And what you just mentioned, that schedule pressure That's another root cause that's in there. Is there some kind of a pressure that's being put on the employee, either on purpose or inadvertently?
Yeah.
Where the employee feels they need to do these kinds of things to get the job done.
That makes sense. All right. We got some more pictures.
Yeah.
All right. That's an old phone.
Yeah. So this is an example again of an inadvertent operation. You can see those little Dixie cups there that are over top of those buttons.
Okay. Yeah.
Yeah.
There's a lot going on in this picture.
There's a lot happening in this picture. Yeah. And you can see this.
There's so much to monitor. Like, I don't even.
Yeah. So this is, I believe this is a tugboat or a ship, a small boat, like a tugboat or something. This is something I've seen.
So what are the Dixie cups? Don't touch.
My guess is that's an emergency shutoff for the engine. Is my guess.
Okay.
And they don't want you accidentally turning off.
Well, if you're like me and I see clutter or trash, I'm going to be like, that needs to go, throw away. Yep. There's no label on it. I mean, even though it's like temporary, there needs to be something to say like,
why is this here?
Yeah, why is this here? This is covering it for a reason, or whatever.
Right. If you're finding that you have to put, again, workarounds like this, because I imagine the reason they did this is somebody kept accidentally shutting the engine off, is my guess. I don't know that, but my guess is the reason they put the cups there is somebody kept pushing the button by accident. Well, then that's a poorly designed control. If the human keeps accidentally pushing things, well, then it needs to be designed so you can't accidentally push it. Now, this is a good initial thought, but we probably need something a little more permanent, like a little cover that goes over it, spring-loaded cover or something like that.
Okay.
So nothing wrong with covers. That's okay. Just not Dixie cups. That's probably not the right answer. Yeah, here's another one, inadvertent operation, right?
Oh, yeah.
Yeah. Probably, again, you don't. So another way to think about this is if you do have emergency controls, which are fine, if you need something to emergency shut something down or hopefully not pull the wings off, but an emergency kind of button, you probably don't want that around the normal operating areas. You want that off to the side because you're going to be fingers and hands and elbows all over the place over here. And if you have something you don't want operated unless you specifically need it done, well, then that probably ought to be off to the side, not next to the next to the recline button on your airplane there.
Right, which is somewhat similar in its design with that kind of lever up, down, on, off.
Good point. So even looking at how it looks, the way it's designed there, it looks very similar and it's very easy to operate the wrong way and grab the wrong way.
Well, and from an airline perspective, you can't. There's no way I could get down there to see, so I'm just going to feel for it, and that must be the switch.
So that's a great. I remember as several aircraft I've been on, there's like a dozen buttons down here on some of those stupid things, and if I got my head down there and studied it, I know what they do. But what you really do, you just reach down there and start pushing buttons till it does what you want it to do.
Yeah.
So you hopefully don't have anything that's really important down there.
Especially if you have a neighbor beside you. I had somebody who was trying to charge the USBs to charge your devices were actually at the bottom of the seat, but somebody was like way down in my space trying to find the. I can help you plug that in.
Is there anything I can do for you here?
Because you're all in my space. It's different when they have it on the seat back.
That's right.
But this plane didn't have it there. They were.
I've had those before too. Yeah. So it's not always physical controls that we're concerned with too that can cause humans to have problems. In this case, obviously, somebody stuck a rag in this alarm horn or this. It could be a loudspeaker. I'm not sure exactly what it is.
Trying to dampen it or silence it some.
It must be too loud. So somebody stuck a rag in there. Well, it's probably poorly designed. It shouldn't be that loud.
Yeah, that's makes me think of in my layout of my house where my kitchen is, open floor plan. Anytime we start cooking, we're making bacon, that chirp starts going off. Yep. So the annoying thing to do is to take it down. Well, now that we've done that, we just
removed an emergency safety feature.
Yeah,
right?
It's doing its job.
It's doing what it's supposed to do.
Yeah. So now that we've muffled this alarm or whatever in this picture, there's a bigger problem going on.
That's right. Yeah. We had and being loud is also a problem. We had on my submarine, we had an alarm that went off for a particular problem. And when that thing went off, it was deafening. You couldn't think it was so loud. And while it was an important alarm, you immediately had to take action when this alarm went off. it was so loud that it was almost hard to take action because it wasn't painful, but it was entirely distracting.
Yeah.
And until somebody silences that alarm, you're almost paralyzed until it stops. And that alarm is too loud. There's no reason for that alarm to be that loud. So it's not just physical control sometimes. It can be the environmental conditions. You know, that's the sound. Is it too bright in this room where I can't see what I'm doing? It's so bright. Is it dark in the room? Those kind of things all feed into human performance and human engineering.
Right. It needs to be audible to a certain degree, especially if you're wearing Safety Pro and things like that. If you can't hear the alarm,
that's right.
We've got to think of those other environmental conditions as well.
Yep.
That's a good one.
So all this feeds together. And again, when somebody makes a mistake because the alarm is so, they didn't take the proper actions when the alarm went off. It's easy just to yell at the guy until you go down there and realize that the alarm is so deafening that you can't even think straight.
Yeah.
So these are all human engineering issues where it's easy to blame the employee, and yet it's not really the employee's issue here. This is just another example of how you arrange and place things in your work environment. And
okay. This is like a thing. It's been added on top of the photo.
Yeah.
Okay, I'm like, what is it? A cat? What am I looking at?
Yeah,
okay,
I tried to pull that picture, that finger off, and it's permanently attached to this picture, so I can get it off. But, so when things are in your work environment that are sticking out, that are in your way, that cause your body position to be unusual, these also can cause human performance issues where you're...
like cramped quarters.
Yep, that's a great example, where you're trying to reach a particular control and you can't get there because there's something in the way and you got to work around it.
You're putting your hand on your radio, but it turns on the...
turns on the emergency flashers.
Yeah.
That's perfect example of arrangement placement. Perfect example. Yep.
Yeah.
Sometimes you have, while this is a physical obstruction, you may have a thermal obstruction. For example, there's a hot pipe and you need to reach past it to get to a control or a valve. While that's not a physical thing that's preventing you from reaching something, it's still causing you...
It's a placement issue.
It is the way that's set up. So thinking about maybe not how the equipment is arranged when it's shut down, but how is it arranged when it's up and running and hot? It could be completely different how you are going to operate that piece of equipment. Because when it's cold, I can just reach across this thing and lean on it.
You've got to look at different conditions.
You have to look at all the environmental conditions when you put things together. And engineers sometimes think of these, and sometimes it doesn't occur to them until after it's up and running. It's like, that's going to cause issues.
And there's things we do out of convenience too. So
that's true too. Yeah, it's just seems easier to set it up this way, but when you actually try to operate the piece of equipment, it doesn't quite make sense.
Yeah.
For example, ease of maintenance. Sometimes you arrange things to be operated well, and then when you try to do maintenance on that piece of equipment, you can't get to it because it's covered up by stuff. Submarines were that way. Half the equipment we had, you couldn't. It was terrible doing maintenance on it because everything's crammed together. And it's set up to operate properly, but when you have to go change that filter out over there, you got to disassemble all kinds of stuff just to get to the silly filter.
This just makes me think of trying to get my Christmas decorations out of the back closet, and it's like, I don't need it every day.
Right.
But now it's this daunting thing of like, oh, great. And this is small scale. I mean, I'm talking about Christmas decorations, but thinking ahead, like maybe where could I put this? I know I'm going to have to grab these every year. Yeah. Why do I tuck them away in such a hard to get spot?
That's a great example. We don't really think about it until that one time when I need to do it. And I don't expect engineers and people to think about everything. I mean, you don't think of everything, but you do have to think during your root cause analysis and your investigations, why did the guy make that error? And it could be because of where it's placed and how it's arranged and where things are located. So all things to think about. I don't want to go too deep into this one. I just thought this was funny. This is in, I think it was in San Francisco or Los Angeles. I can't remember. This is an outdoor bathroom. It's a special, I don't want to say outdoor, but it's an enclosed...
There's a lot going on here. Okay.
Well, that's the point. So if I had to use this restroom,
let's see. Let me look now. I haven't seen it before. Okay, you can use it if you're a guy, if you're a girl, but you can't smoke. It's handicap accessible. A dad and a
Guess
son.
You can take your kids with you.
No, but they're male, so it's dad and son only.
That's true.
So daughters and moms, sorry.
You're out of luck.
Yeah.
And then there's instructions.
And a time limit too. Is that all right?
This thing automatically cleans itself every now and then. So when the door shuts, you have to wait a few seconds for this thing to do its cleaning cycle because it sprays the whole thing down inside. It just cleans everything. And there's I can't imagine a single person who's actually going to read this sign.
Yeah, and I just read it and it still doesn't make sense. I'm like, I got to go.
So exactly, that's not the time that people are going to stop and read signs. And this is a great example of how a lot of people or a lot of companies try to fix things with signs.
Oh, yeah, just put up another sign.
Put up another sign.
Go into the doctor's office. Just sign.
All these signs.
Well, put up a sign.
I told you. It's right on the sign. I told you you're going to get sprayed down if you weren't careful. I told you right on the sign.
Right.
Nobody reads signs.
No, they don't.
So anytime your corrective action is to put a sign up, again, that's good for a week or two. And then nobody reads that sign again. It's gone. So signs are a very poor corrective action, and it's not a very strong human factors corrective action. People just don't read signs.
And I can barely read that phone number on there. Also, it's at the very bottom.
Yeah,
for more information,
it's
in one language. But even the illustrations up above, all I really get from this is don't smoke and
and it's a bathroom.
Stay out of the 20-minute window.
I guess, yeah. It's so signs are just not a good way to fix things. People don't read signs. So
like this lady doesn't read signs.
Don't read signs.
But where's the wet paint? Is it on the walkway or the bench?
Is it the red bench? Is it the black piece? What is the wet paint on here? And this is just what you just mentioned. This is a great example of people just do not read signs. They don't.
Well, she's going to find out.
Yeah, she's going to find out when she stands up. So we could think to ourselves, so what would have been a better corrective action here, rather than wet paint signs on the ground? We probably could have put a barrier on this around it so people couldn't get to it. We could put some tape across so people know, I probably shouldn't be sitting here.
Right, because if the paint's wet, you can't put the sign on the wet paint.
Right.
But a barrier would be better.
Some cones or something.
Or painting it at a time where there's not as much traffic. Like if this is downtown for where we live, downtown doesn't even start waking up until a certain point of time.
Right.
So maybe paint it early and know that it takes, an hour or two to dry or have... I wouldn't want someone to have to stand there and literally watch paint dry.
Well, that's an option if you need to, but it's not, you're right. That's I could have a guard there, a physical guard. I could do that. But
maybe take the bench, because if it's easily, like it's bolted or something, if you could remove it, go paint it off site.
So
and then
remove the hazard, right?
Yeah,
Get
replace
the hazard
it.
out of there. Yeah. So these are things that people should be thinking about when they do things instead of signs. Signs and training, telling people what to do. I'm not saying don't do those, but they're very weak. And the general public, especially, do not follow signs. They just don't. And you can yell at the person and say, well, you'll learn. It'll be your fault. Well, yes, but wouldn't we rather not have the person sit in the paint? I mean, that's really
and it looks like somebody already spilled some paint, too.
Yeah, it looks like they made a mess when they painted this thing. Yeah.
Okay. All right.
This is our last one. So this is just kind of a... My goodness. People, designers, and sometimes they just follow, this is what my blueprint says to do, so that's what I'm going to do. And I have about 100 of these kind of pictures of people with silly designs that made it, while it follows a blueprint, it is no longer a usable piece of equipment anymore. So I can't use that driveway anymore. It's done. So anyway, there's a lot of this kind of stuff about how people...
That mailbox is way up there, too, in the middle of the drive.
Oh, yeah. I hadn't really noticed that. Yeah. So anyway, so those are some thoughts on human engineering and human-machine interface. There's a lot of things to think about. It's something that most people are not trained in, especially investigators. They just... When you see it, you think, oh, yeah. But while you're doing investigations and all you know is the guy pushed the wrong button... Your immediate thought is, well, the guy shouldn't have pushed the wrong button. So let's go talk to that person so they don't do it. So
kind of thinking ahead here too, all this makes sense, but there's some industries, some companies that have, this is how the machinery was made. We don't make the machinery, we have the machinery here, we operate it, we use it. What can they do if they're seeing that there's some placement issues or things like that? What are some, I don't want to say workaround, but what can you do when it's something that somebody else designed? It's a product that you own or machinery you're utilizing.
Really good question. So obviously we can't redesign every piece of equipment in our plant. But we can do what we would consider a safeguard analysis. So you could look at it and say, well, what can I do about this? And safeguard analysis, you can ask yourself, can I remove the hazard in the first place? Can I get the people out of there? Why do I have people in this area where they could accidentally push buttons and cause problems? Can I put guards around it so that people can't get to it? These are all what you would find during a safeguard analysis, and see what else can I do? And we have what we call our safeguard hierarchy, and you want to start at the top. You want to see if you can get remove the hazard, remove the target, guard the target. Way at the bottom of our safeguard hierarchy are signs and training. Way down at the bottom, because they don't work well.
Is that something we can share, the image of the safeguard
Yeah,
hierarchy?
sure. Yeah, we can put that on.
So we'll add that to the screen, and then we'll add some links below that discuss safeguard. We have a lot of articles on our blog that talk about safeguard hierarchy, and what we've talked about today as well.
Sure.
And if you're experiencing some of this placement equipment issues and things like that, instead of putting your Dixie cup or your plastic cup over, the control is a temporary fix. Talk to the manufacturer. Say, unless you can make these things yourselves, say, hey, we need some kind of hinge that will cover this, and kind of thinking outside the box in a lot of ways.
I just want people to think more, instead of looking at the human. Remember, this is human-machine interface. It really ought to be the machine side, and because the human is going to do what a human does, and trying to train them to do differently is not very, it doesn't work well. Humans, I don't want to say they're not trainable. They are, but you have to train each human separately. And there's just going to be somebody screwing it up because we're humans. So you want to make it hard for the human to screw up. And that's where the human engineering section sets in.
All right. And last thing, we've got a course that talks about this. There's segments in some of our other courses, but one specifically that we think people should check out.
Yeah.
We tell them about that.
Yeah, we have our Stopping Human Error course, which is a 2-day course on these kinds of things. This is a piece of that course. It talks a little bit about how to first of all recognize the errors that humans can make, and then different tools that you can employ to help prevent those humans from making those kinds of errors. So it's a really good course. It's a 2-day course. We can do it either on site or we have in public courses also. So it's a really good opportunity to see some of these kinds of things and ways to put good corrective actions in place.
So we'll add a link for that as well, the Stopping Human Error course. And thank you for going through all these pictures. It was a fun time getting to talk about all that. And we will see you guys next time. Thanks for watching.
Bye-bye.